everyone, and welcome to today's episode of Where Does Your Journey Stem From, hosted by myself, Dr. Karina Minardi. Today, we welcome a very special guest, Anoop Kiran, who is a graduate student at Brown University. Let's all welcome to the stage, Anoop. Hey, Anoop, how's it going?
Hi everyone, Karina, thanks for having me.
Yeah, of course. Excited to have you, obviously. So, Anoop is a second-year Engineering Ph.D. student and an NSF Graduate Research Fellow at Brown University. His research focuses on the physics-informed control of aerial robot, or drone, swarms in unsteady environments. This is going to be fabulous to get into. Before joining Brown, he graduated with a Bachelor's of Science in Aerospace Engineering from the University at Buffalo. As a mentor for underrepresented students through the National Science and Technology Medals Foundation, he aspires to make STEM accessible and equitable. Outside of his academic endeavors, he enjoys flying as a student pilot. Anoop, we're really excited to have you. And usually, our first question to guests are, your bio says a lot about you, but let's actually, from your perspective, tell us a little bit more about yourself.
Yeah, like every other student growing up, I had always had a passion for STEM. The reason is because I've watched the airplanes fly high up in the clouds and always wondered what what was the reason behind it and the physics of flight in general. So that got me interested in the field, and I've worked towards that direction. And now I'm a PhD student working on a research in that area. Um, so aside from that, I've been really excited about aerospace in general. The field itself is fascinating, and there still remains a lot of questions to be answered. So it's up to the students in the current generation to look at these kind of exciting um, nuances in this field.
No, I really love that. Usually, folks say there's an individual that impacted them, but I think a natural occurrence, or even some things as like flight. I used to live in DC, and I was in the flight path of Reagan, and it was so fascinating to me. Some of the airplanes were really close to my building, and some were not. And I was like, "Are you going to overshoot the runway?" So it's just I totally agree with you. Um, so how did you? I mean, you have this love of airplanes. So how did that sort of translate to an actual academic program for you?
Yeah, so it started in my eighth grade, the fascination for airplanes. I was taking a domestic flight here, going from Charlotte to Dallas. So it was kind of a short flight, but in that flight, I realized that I wanted to get a view of the cockpit. So I asked the pilot in command at the end of the flight if he could give me an exposure or at least a view of the cockpit. So he kind of explained all the parts and showed me the intricacies of systems in general, and that got me excited. Moving from there, in terms of a research direction, from then on, I've invested my time outside classes as a high school student, working on research projects, and that helped me build my experience. Moving on as an undergrad, working on side projects, also involved in research projects and internships, kind of helped pave the way towards graduate school. But I've looked into many different aspects of airspace because I've felt the field itself is really challenging, and there are a lot of questions that remain unanswered. Um, and these experiences culminated in me wanting to go further and seek guidance and quench my thirst for what's out there. And that got me interested into flight in general, not just restricted to airplanes, but looking into drones that I'm looking at right now, how they fly in unsteady environments, which is very realistic because if you have been in an airplane, you would have you would have probably been exposed to turbulence where pilots in command probably instruct the passengers to buckle their seatbelts. So you probably already know how important it is to look into these kind of aspects in the field and to dive deep into such challenges that are realistic, especially in the applied research area.
So you mentioned that you were involved in research projects as a high school student. So did these pertain to aerospace, or was this sort of an exploration of what else was out there?
Yeah. So The my experience as a high school student was really general. So for me, that was probably the stepping stone. I put myself out there wanting to explore every single opportunity that I wanted as a high school student. So this included DECA, other sorts of research experiences that my school had after hours. So we had a instructor in the STEM department who was really excited about research and STEM pedagogy in general. So they made it a point to enforce research very early on so that students could get an exposure to this area and at the same time think about what questions they could answer moving forward in their undergraduate journey. So I was fortunate to be a part of this program where my cohort itself had 5 or 6 other students who were interested in research, and the projects that we would do would be very simple, programming a robot which would water plants or other sorts of activities which were outside aerospace. But in general, that kind of helped me think about these problems and um, find out ways that I could implement solutions to it as an engineer and think differently. Maybe that's probably what got me interested in thinking like an engineer and wanting to be an engineer. So it all started from um, my high school experiences. So I'm forever grateful for that.
Yeah, no, absolutely. And I think your discussion around the examples of saying that you weren't necessarily wed to aerospace engineer at that point in time, but actually thinking about, what other opportunities are out there, I think is critical because all too many times, I think there's, I've coined the term about embracing the randomness that if something is presented to you, whether it is a networking opportunity, whether it is a research opportunity, whether it is an exploratory opportunity, just a conversation, that you should just embrace it. That say, because there's one of two things that'll happen. You either will love it and you'll really like it and then maybe want to pursue it, or you'll hate it, or maybe not hate it, but not really like it all that much, and you'll know not to pursue it, which is actually just as worth the pursual. So I think there's that piece to it. I think I would like to explore a little bit more about, you said something really tangible around skills and training and thinking like an engineer. And so if you could elaborate on that a little bit more, I would really appreciate that, because I think that is sort of our mission at STEM from is exactly that.
Sure, yeah, and just like you mentioned, it's very important not just to find things that as a student would like to do, but also to find the dislikes, because that helps position themselves on a trajectory that they could follow in the future. So likes and dislikes are very important to analyze, especially at an early stage. And regarding what drew me as an engineer, I would say mostly it started with programming. I wrote my first C code when I was in my fifth grade, and moving forward, I built on that. So this was basically a mini game, which would be a Pac-Man game, which would instruct a specific move on a board. But as something as simple as that made me think about how we could change that or change the way we would approach solving such problems, whether we'd be interested in moving the track in a specific orientation or coming up with a way in which tracks would not move at all or finding the limitations right of such a system. So what a code entails us to do is actually making a system autonomous. Like recently, with the advancements in technology, we tend to overlook how far technology has advanced in terms of autonomy, whether it be driving a vehicle on a cruise control or changing, having lane departure features. But it's extremely important to think about the fact that almost everything in the background is run by code, which is why it's fascinating. So programming, I'd say, was the first skill set which kind of complemented my interest in engineering because everything kind of went hand in hand, at least for me, after I started learning how to program a system, debug, which is probably the most painful thing, and trying to make a system work, and learning from failures. Obviously, not every code runs, and there are sometimes reasons where it might fail to an extent. It might give an error code which I might not have seen before, but learning from it has probably helped me improve my course of action over time. It has made me stronger as an engineer, and it has helped me realize that not all problems are solvable, right? There are some tangibles that are out there when it comes to meeting the requirements of an objective, but there might be cases where everything doesn't work out as intended, and those could be really good lessons to take away from any experience that someone could have. Um, but as an engineer, I would say programming was probably the most important skill set, which got me into it. Aside from that, having the right mentors, seeking out for mentors and leaders who have helped me realize that these were my strengths in this area, which was basically taking up a project, which could be something as simple as reverse engineering a toaster or something you might find at home, um, breaking it apart, analyzing the components, and finally improving the system or putting it together, right, in a way that improves the lives of others. So I feel like there's so many things that you could do. Having an engineering background or building such a mindset in general, that it's just amazing. And this it's a field which makes someone independent, and I feel it's really exciting to be involved with all this.
Well, and the other piece around engineering, which I always enjoyed, was that, there was software, computer science engineering, there was mechanical engineering, there's civil engineering, there's electrical engineering. And so you can take kind of the overarching topic and then really delve into what actually, aligns with your personality traits, because not everyone is sort of inclined to either hands-on work, more people like coding, so on and so forth. And I really liked your discussion around learning from failures. I could think, reflecting back on my graduate school days, and research days in and of itself, thinking around, it was never when an experiment actually worked that I learned. It was always when it failed. And it could fail because of hardware. It could fail because of software. It could have failed because the experimental methodology was not, really solid in the thinking. And precisely to your point around, okay, you got to take the entire instrument apart, figure it out, understand where it is, what's the problem, define the problem, solve the problem, and then put everything back together and cross your fingers that it's going to work just as well as it did before. So things like that, which really introduce you to how systems form, function, in just in general work. You did mention, however, the right mentors and thinking about mentorship. So could you think about the mentors that have impacted you, and talk a little bit more about them in particular?
Yeah, sure, absolutely. I would refer to my undergraduate advisor, who Dr. Lagour. So Dr. Lagour was the first person who got me interested in the field of flight dynamics. And flight dynamics entails everything from stability of a system, which could be an airplane or a drone or anything in general that flies. So the field itself was really fascinating to me, and I wanted to delve deeper, obviously, because of my previous experience as a student pilot. Honestly, being up in the air, asked to land under turbulent conditions, like all you can do is think back to your training and have certain set of requirements that you might have fulfilled, or um, steps that you might have followed to approach the landing strip, right? So but as an engineer, you could obviously improve an airplane's control system, and that would make an airplane more robust to turbulent conditions. So Dr. Lagour was the one I reached out to take up on this project because I found it really fascinating, and it was a student proposed project. So, drawing from my experience, I thought this would be something really fascinating to work on. And first thing that he did as a mentor was sit beside me and talk to me about my experiences, how I would have approached this problem when it comes to turbulent conditions, how I would think about the problem, how I would distribute it into parts that would allow me to improve the system or find the root cause. When it comes to a damage or a failure in terms of landing. So, as a mentor, I think one of the most important traits is to have time, and is to have the initiative to sit with a student and be able to think about their interests, objectives, and find the right match so that they could set them on a track that's optimal for their future. Right. So this is something that Dr. Lagour did, at least for me at the initial stages when I brought up a problem. Um, and I'm so very grateful because it helped me think about the intricacies of how I would end up solving it. And like I said, one of the most important things, according to me, is not being given an answer, but to think independently and to come up with an answer, which is what he has taught me, and that has helped me become an independent researcher over time and has prepared me for graduate school. So that kind of training, support, and mentorship at my pivotal stage when I needed it the most was something that I'm grateful for.
So you are now, fast forwarding a couple years, you are now a mentor with NSTMF. And if you think about mentoring all of those students, what are the sort of personality traits and or skills that you have mastered over the couple of years, not only through seeing great mentorship, but also knowing maybe perhaps how you would prefer to have been mentored through bad mentorship or maybe lackluster, whatever have you. So what are some of those things that you focus on?
Yeah, absolutely. So in NSTMF, the National Science and Technology Medals Foundation, I'm an in STEM mentor, which means that I promote diversity and inclusiveness in STEM. So the key objective here is to support students, have them um, get some sort of instruction on how they could navigate college and be part of a greater objective. So, especially students from disadvantaged backgrounds tend to feel like they might not fit in well in a college environment, which is something that affects not just the retention, but also their future, most importantly. So, it's very important to think about their objectives, their interests, and to find out an optimal path for them, um, like my mentors have done at critical stages of my career. So, what I as a mentor, instant mentor, do for students is to organize workshops for them, which might not be the basic workshops related to how someone would go about navigating a class or an experience in general. But here we're thinking about their day-to-day lives, how they might budget their expenditure, or think about a research plan, how they could navigate some sort of difficult conversation with their instructors. So these are all like crucial conversations which would help them prepare to be successful in their undergraduate journey. So currently, the program is restricted to undergrads at Harvard and Cal State Long Beach. However, the goal is to expand that towards other schools too, because it's a program that's run by AAAS, American Association for the Advancement of Science. So I'm so glad that students are able to ask upperclassmen questions and have that answered through these workshops. And at the same time, I'm paired up with two students who can meet with me monthly, ask about anything they want in general, and get a feel for that experience. Um, and it's extremely important for me, at least, to pay it forward because I moved to the United States about 6 years ago when I was 16, and my experience itself was completely different from what someone would have gone through as a high school student who was born and brought up here. Um, and I think that would help shape a student's future, and I would have a lot more to share about how I would have gone about navigating a problem, and I hope that would influence someone's life. That's the whole objective here.
No, that's really powerful. And that's, I think, wonderful words of wisdom. Um, so let's transition now because you're mentoring students in your graduate lab. And I'm really interested in learning a little bit more about your research. What are you focused on? What are some of your hypotheses? So if you could give us a little bit of an overview of your research, that would be really beneficial.
Sure, absolutely. I'm most excited about that. So, um, if you've ever seen a drone fly up in the air, you'd probably have noticed that there are four propellers which would balance a drone. high up in the sky, and we would alter the thrust, which is the force that's generated for it to levitate in the air. We would alter the thrust on those propellers to make it roll or pitch, which is to rotate in a certain orientation. Um, it's it's extremely beneficial to see drones flying higher and higher, but one of the biggest disadvantages is that it consumes power. So we would have to think about the right combination of systems configurations that would help us fly a certain range when it's a tasked mission. Also, at the same time, ensure that it's meeting the objectives of the mission, right? Which is to perform search and rescue or other sorts of applications that we're interested in. One of the downsides of having these propellers rotate is that it generates a huge column of air beneath it. And this huge column of air is referred to as downwash. So my goal is to study the effect this downwash would have on other drones, surrounding drones in a swarm, and how that would induce certain unsteadiness, which would affect the stability of other drones that might be flying together in a swarm. And you might ask the question, why swarm? Because a lot of tasks that a single drone cannot perform, like search and rescue in a collapsed building, is now possible with swarms because they can um, kind of distribute the tasks between different drones and then go about navigating different rooms, get a feel for an inspection area, and then finally relay all this information. We can stitch all the images together to get a complete view of an area that's being inspected. Um, Say search and rescue. However, there could be so many other applications we could think of, which is where my research falls in studying these effects and the stability of drones in general. But I'm curious about last mile delivery, which is a big thing these days, especially holiday season when we like an object, when we like an item to be delivered as quickly as possible, right? But it's very difficult, whether it be a snowy day or the traffic might be really um, difficult for us to navigate through. So we might want a drone to deliver a package for us or get an item to us as quickly as possible. So it all comes together in the field of robotics, especially knowing how effects such as unsteady effects due to gust and trees and other obstacles um, which might affect a drone from navigating in an environment. So knowledge of such conditions and having a plan in general really helps the field itself. So I feel it's a research area that's kind of exciting, and
No,
at
it's really
the
super
same time,
exciting.
yeah.
Yeah, for sure. I guess a rather ignorant question on my part is, are you simulating these scenarios? Do you have drones that you're swarming around that you're testing out? What does your experimental methodology actually look like?
Yeah, so that's a very good question. Part of the reason I got involved in this project is because I wanted to do things hands-on. So my background itself is doing a lot of simulation related work, and I didn't find it really fascinating. Like I mentioned, it's important to learn about what someone likes to do and also what they dislike, right? So um, during my early undergrad experience, it was mostly simulation, which I didn't really enjoy. So I decided for graduate school I wanted to do more experimental work. So for experimental methodology, we're actually testing these drones out in gusty conditions. So we have a fan which induces turbulence, very similar to an airplane, like I mentioned. But here we have a fan which would generate a certain speed, or we could also test it in a wind tunnel. So wind tunnel is specific, more tailored towards aerodynamic testing, where we have a turbine or a fan that rotates, and a subject that's of interest to us is placed in the middle, and then we test out different conditions within the test section that's of interest to us. So, optimizing the design, changing conditions like rotating it by a certain angle or changing the orientation are all kind of the things that we'd be interested in under those testing conditions. But it kind of gives a realistic exposure to conditions that these drones might be um, itself exposed to, right, in real life. So that's what we're interested in, and that's kind of like the experiment methodology, testing it out in those conditions under the parameters that's of interest to us, and fixing certain parameters, altering the other ones, and finding the effect that it has on the drone in terms of stability, and drawing conclusions from that so that we could make a control system which would make the system robust enough to mitigate such unsteady environments and conditions.
So I guess a question then around use cases, right? Is so you conduct experiments, you find results, you publish results, then what? I mean, do you anticipate um, Amazon harnessing the work that you've done in order to help with point of delivery for objects? Or explain to me a little bit about the use cases there.
Sure. Yeah. So right now we're partnering with ONR, Office of Naval Research, where the goal of this objective is swarm stability. So once the work is disseminated in terms of research outputs like manuscripts or scientific publications, the goal for us is to integrate it into an actual system for deployment in search and rescue. Amazon is also interested in the sense that they'd like to enhance their product delivery. Right now, Google's Wing has started certain um, last mile delivery objectives down at Dallas. So the goal for us in general is to make the the research as valuable as possible, not just to the scientific community, but also to the applied research community and commercial companies out there, so that this would be valuable for people in general. So the results still translate over, right? Knowing the unsteadiness is extremely important because now they could build a system that would integrate this and take this into account. We have been hearing about drone delivery for a really long time. However, regulations have been restricting it, and part of the reason is that a lot of people do not like the noise that comes from drones, right? If they're flying in environments, it could be something that affects normalcy. So it's extremely important to integrate technology in a way that improves people's lives, and at the same time, it it should be groundbreaking enough so that it doesn't affect their lives, right? So there's a balance right there, which is why it's extremely important for us to think about such problems. But it's a coupled problem because noise is a factor. We have to take into account the conditions which we are currently doing as part of our research. But once these aspects go hand in hand, I think it would my vision, or at least I see it being implemented in our day-to-day lives.
So, knowing what you know now, when you think about a career trajectory, postgraduate school, I know you're second year, so it's a little early to think about that, but it's always good to think about that. Where are you thinking of your next steps and aspirations?
Yeah, so I've been fortunate to work alongside scientists and engineers who have motivated me to question the unknown as part of R&D work that I've done in the past. So I've had internships working with Boeing, NASA JPL, and Draper, all were in the direction of aerospace field that made me realize that I wanted to uh, work on something that would enhance the industry and kind of help build on a system uh, that would be helpful in the applied research area. And I keep saying applied research because R&D has motivated me to think in that direction. And a lot of research that happens in universities are mostly in the fundamental research route, the TRL level one, which is not really beneficial, right? It's hard to translate that research into what happens in real life. But R&D has kind of opened my eyes towards what's being done um, at collaborative environments and national labs. So I'm really interested in taking things forward, and that's part of the reason I decided on this project in general, because I see the applicability, I see how it's being implemented in general, and how it could shape someone's life. So being part of it makes me kind of think back to my projects and why I ended up choosing in the first place. So that motivates me to keep going forward in that direction. But just like you said, it's many years from now. So I think I foresee myself working for a national lab, solving such problems related to applied research in the aerospace field. But it could be broad. It might not be restricted to drones in general, but anything in the aerospace is something fascinating for me. So I'd be more than interested to dive deep into it.
Yeah, and you can also set up your own lab too to continue on with that R&D journey. to think about that, which I really like. And I liked your point around applied research. For me, it was interesting because most of my undergrad research was very much application based. And so I always knew that the reason why we were doing it or the use cases around it. And then I actually made the decision for grad school to go a little bit deeper in theoretical because I wanted to understand the fundamentals. I wanted to do a little bit of experimentation so that I could really grasp what the fundamentals of how the instrumentation worked. And I did, but a byproduct of that, unfortunately, was why am I doing what I am doing? These experiments are so theoretical in nature that, and I did a lot of similar to you in that simulations, thinking through, elemental molecular simulations, which are great to know as fundamental again, but really, really difficult when you think about applied sciences. So totally agree. I know we're nearing the end of our time, so I want to be mindful of that. But I do have one last question for you. You've given us a lot of, I think, discussion around, tips, tricks, what has helped you throughout your career path. And so I'm just thinking, if you could reflect, 10 years ago, what would be the words of wisdom that you would have told yourself 10 years ago?
I would have told myself to take things calmly and to go with the flow, not to follow anyone's direction, but to have unique perspectives and ideas of what to achieve. Um, the reason for that is over time I've realized that it's um, okay to be someone that's unique in the crowd. You don't have to follow the rest of the crowd and pursue a track just because everyone else goes to graduate school, right? It's more of an interest that's unique to that individual, and it's very very important to find that, especially at an early stage, because then you can kind of channel your trajectory based off of that. Um, and that'll be extremely beneficial down the road because you would have taken a path that's less traveled, but you've realized your weaknesses, strengths, and at the same time, you're more or less personalized it for your journey. That's what I've realized. Aerospace, it's not for everyone. Um, I've also realized that there are certain paths within aerospace that I might not like, but testing out the waters early on kind of helped me figure that out. So it's very important to think about such reasoning very early on in one's career, and having that idea helps later down the road in helping personalize their journey.
Yeah, personalization of a journey is for sure. Not everyone's journey is going to be the same. And I mean, the name of this podcast is "Where Does Your Journey Stem From?" So it's like what was the originality of your journey too, and how did what was the inception point? So
Absolutely.
with that, Anoop, I love this conversation. Your research is totally cool. You've done some really fabulous stuff. So I look forward to seeing your future and how it grows and where you determine to take your next step. I think that's really, really key. So thank you for your time and for your contributions to science. And then obviously to our listeners, thank you for tuning into this episode. And always remember to ask yourself, where does your journey stem from?